PinkDraconian, I started watching his videos while I was in Hack the Box, and it was like a young talent. I think he messaged me that, hello, I do these videos, and I watched him like, okay, you are amazing. And we started the series with him. Now he is competing, that's why he cannot be live with us today. He's competing at the European Challenge and representing not to the worldwide challenge that Europe has their own group, America has their own group, Latin America has their own group, so Asia has their own group, Africa has their own group, New Zealand has their own, no, Australia has their own group, and they fight all with each other. It is with young talents. You can check it out, it's ICC. So yes, PinkDraconian, because he's so young and he's so talented, he's playing there with us today, but we couldn't miss him from the talk. So here, he's solving some of the gems and most liked web challenges from past year. So if you wanted to see some live web hacking action, tune in for the talk of PinkDraconian. I am adding it now to the stream.
I'm PinkDraconian, and today we are going to be walking through 2 challenges of the Cyber Apocalypse CTF from last year to get you guys kind of excited for this year's edition because it's going to be amazing once again. Thanks a lot, Hack the Box, for allowing me to do this talk. And well, let's get into it. Today we're going to be talking about web challenges. We're going to be talking about client side. We're going to be talking about server side exploits. We're going to be doing all of that fun stuff. But before that, you can see that I have a green box around me here. And that's not because we're going to be hacking the box, because don't hack me, but today we're going to be hacking outside of the box. This webpage. I know that was a pretty terrible pun, but yeah, we're going to be hacking this webpage here, The Galactic Times. And this is a pretty cool one. I mean, it looks like a newspaper for aliens. There is probably a bunch of very interesting stuff to read here, which we're not going to be doing, because we also got the source of this page as part of the challenge. Now I've just unzipped all of that and opened it up here in Sublime Text. That's the editor that I like to use for this kind of stuff. And immediately we have some JavaScript files here. We have an index.js file. That's probably the main one we want to look into. And this looks like a Node.js application. We can also see at the top here that it requires Fastify, and Fastify is a web framework for Node.js. So this is hosting a website. Now there's a bunch of code to look through here. There is a database, a bot, but the most interesting thing that I like to look at in the beginning is the roots, because that may show you some new endpoints that you didn't yet know about. So in the roots here, we can see, first of all, a endpoint slash. That's the root endpoint, and this will just show that main page that we saw earlier. However, the one below that is /alien. And this is interesting. Well, let's quickly try to visit that. So /alien. Oh, only localhost is allowed. Huh. All right, interesting. So we are not actually allowed to access that. Why is that? Well, we have the source code, so we can just see and figure out why that is. Well, it says if our request IP is not localhost, then it will return that 401 only localhost is allowed. But if that's not the case, then it's going to return views/alien.html. Now, luckily, we can look at alien.html. So let's look at what alien.html contains in the views folder here. And here we see alien.html. It contains, well, probably some alien language, but it also contains a fake flag in this case, but it is safe to assume that on the server, the real flag is placed there. So that's what we want to get. We want to achieve access to this /alien endpoint, but for that, we need to be localhost. So we have an end goal of the challenge now. Now we can think about how we would be able to get there. The first thing that I can think of is that Fastify might have some kind of issue here. It might run in an outdated version that allows us to spoof our IP address through any means. So we may be able to spoof our IP address through X-forwarded 4 headers or whatnot. So that's way one that I can think of the top of my head. Secondly, there might be an SSRF, so a server-side request forgery, and that might allow us to control requests that the server makes, and that way request the alien endpoint and get the output. Or thirdly, and this is a client-side exploit, there may be a user running on this server and that user may be looking at some pages. So if we have a way of injecting JavaScript, so through an XSS, into that user's browser, then we can obviously execute JavaScript, make that visit the alien page, and then get the flag. So those are the 3 ways that I keep in the back of my mind that I can immediately think of, well, that is how we could get this data. But we obviously need more information, so let's keep on looking through these endpoints. The next one we see here is feedback, and that's also just going to return a page. So let's take a look at the feedback endpoint. So feedback, and here we see that we are allowed to enter some feedback. So I can enter test and submit it, and then it says the Galactic Federation has processed your feedback. Okay, so that's an interesting one. We also see a post request to /API/submit is possible. That's obviously also very interesting because this is going to do a bunch of stuff, as we can see here. And we can also see that it starts with feedback. So this is probably what happens if you press that button to send your feedback. So we see that an object feedback is created from our request.body, and then the feedback is added to the database. Okay, we could trace that obviously because this is database access, and we could check in the source code if there is an SQLi injection and all of that. I'll always check all of those things, but in this case, for the length of this video, we're not going to be doing that. We're going to be assuming that this is secured. Then we have if that database add feedback works, then we're going to be doing something. Well, what are we going to be doing? The bot is then going to purge data from the database. That is interesting. What is this bot? Well, this bot comes from bot.js here. And bot.js starts with including or requiring Puppeteer. And then it's going to set some browser options here. And then at the bottom, we have the purge data function. What is that going to do? Well, it's going to launch a new browser. So it's going to open up a headless browser, so a Chrome browser most likely. And it's going to, in that browser, create a new page. And it's going to go to the localhost, that's interesting. And /list. So it's going to get the /list endpoint on localhost. It's going to wait until everything is loaded, and then it's going to close the browser once again. That is very interesting. After that, it's going to do a database.migrate, which is pretty much just going to empty the database once again. I have commented this out for local reasons so that I can run all of this locally, but we'll get to that in a bit. Okay, but this is very interesting. We have a way where the local host is checking the list page out. That's very, very interesting because this shows that there is a user checking the local host, checking a page on there. So our third hypothesis, that's a hard word, that said that an XSS could be possible here might be true because, well, we have a user checking on the local host. Now, if we have a way of injecting an XSS payload into this list page, well, then we can trick that user into visiting it and in executing our XSS. Cool. What is that list endpoint? Is that a part here? Well, yes, here we see the get endpoint /list. I'm going to scroll down a bit more. And we see once again that we need to be on the local host in order to get access to that list. But once we are the local host, then it is going to get feedback from the database. And if there is feedback, it's going to reply with list.pug, and our feedback is going to be put into list.pug. Now, pug is a way of templating. So it's just probably going to take our feedback and show that in the list, but we can obviously check that out here. And here we see the pug page, and we see that it's going to do a for loop. And for every piece of feedback, it is going to create a table row and put our feedback directly onto the page. Now that is very interesting because this is showing our feedback, our user input, and it's not being sanitized anywhere. It's directly showing it to the victim. So we can do something very, very simple. We can just insert a script tag with an alert. And I mean, that should work, right? Let's submit that. But there's one issue with that. We don't have a way of checking that list ourselves. We cannot verify that this XSS triggered. And that's a bummer. So what are we going to do? Well, let's just run all of this locally because we have all of the code to do it. So I am going to go into my terminal and I'm just going to run node index.js, and hopefully that works. And as we can see, that works. Obviously, I've done some setup. I've installed all of the required modules and all that, but that should be fine. Now I can go to my local host. Does it say where it hosts it? Yes, on HTTP and on port 1337. And now here I should be able to go to the list, and it shows because we are on the local host. So it shows the list here, and then I can also open up the feedback here. And that should show the feedback page. Yes, there we go. So now I can post some feedback, test, and if I reload here, you can see our feedback on the page, which is great, which is what we want. Now, how are we going to go about hacking this? Well, let's first of all try out our script again. So a script tag with an alert, and let's find out why that works or why that doesn't work. So I'm going to submit this, and I'm going to reload the list here. And we can see that it shows a new element, okay? But there is nothing here, there's no pop-up happening, what is going on? Well, I'm gonna inspect element here, and I'm gonna check out the console, and in the console we see an error. The content security policy. The page's settings block the loading of a resource at inline, and this is happening in the list, so this is probably an issue. Okay, content security policy. What in the world is that? Well, let's go in the source code and let's see where that is defined, and that is in our index.js file. In our index.js file, it's registering a new content security policy here, and it has certain directives, such as a style source, a font source, an image source, and all of that. What is a content security policy? It's a security measure against XSSs and a bunch of other vulnerabilities that define what kind of content is allowed to be loaded onto the page. So for example, for fonts, what is the allowed source for a font? Well, a font can come from self, so that's the own web page, so on a different endpoint on the own web page, that's allowed. Or fonts are allowed to come from fonts.gstatic.com. But any font, if the browser tries to load a font from any other page, it's going to say, nope, not allowed, the CSP is blocking that. And that is what a CSP is. Now there are obviously some other things here. For example, for the style source, there is an unsafe inline here. For the script source, there's an unsafe eval here. This already says unsafe in the name, so that could be interesting, but I don't know. How do we see how secure this CSP is? Because the CSP, Content Security Policy, it is created to secure things, but if misconfigured, it can still cause some issues to slip through the net, and some vulnerabilities can still be exploitable. So let's take a look at the CSP in action on our web page. So if I go into the network tab here and I check out a request, then we should see it in the headers being passed, and here we have it. I'm just going to copy that, and now I'm going to go to Google's CSP evaluator, and this is pretty much just a web interface that's going to check a CSP for us, and then it's going to say tell us how secure the CSP is. Now looking at this, we can see there is a script source that is showing that there is an issue. Okay, well, what is the issue here? Okay, the high severity finding is here, and it says cdnjs.cloudflare.com is known to host Angular libraries which allow to bypass this CSP. Okay, what does that mean? Back to the CSP. The script source says that scripts from self are allowed, unsafe eval is allowed, whatever that means. And then here, any scripts from this website are allowed to be executed on the page. But Google is telling us, well, this website hosts some Angular libraries that contain a CSP bypass, so that might be vulnerable. Okay, what is this cdns.js.cloudflare? Well, that's just a website, and it says it's an ultra-fast, reliable, globally available content delivery network for open source libraries. Well, interesting. It just hosts open source libraries such as AngularJS and all that. Now you can do a bunch of Googling here on how to bypass this, and I came across this quick page, bypass of CSP, and here it says bypass of whitelist, and in this case it contains one exactly for cdnjs.cloudflare.com, and it contains one for a certain AngularJS library here that is vulnerable So this is a very old version, as you can see from the version listing. There's a bunch more versions already. This is an old AngularJS version. I don't even think AngularJS is fully supported anymore. So that is quite dangerous, because this might contain some vulnerabilities. We can even see it says it contains 3 vulnerabilities there. So what this is going to do, this is, well, going to load that script, and that is allowed by the CSP. We're allowed to load that script. Then it's going to create a new ng app, and it's going to do this eval.constructor alert XSS. Well, whatever, this is some kind of exploit that already exists. If we had more time, we could go into it more. But for now, let's just try to see if this executes on our local page. So I'm going to paste this in here and submit this as feedback, and then reload the list. And if all is well, then we should see indeed we get our alert pop up. That is really cool. So this is a way that we can get XSS. We have bypassed this CSP, the content security policy. All that's left to do for us is to get the flag out of the alien page. Now, what do we need to do for that? Well, we need to create an XSS payload that is going to request that alien page, this one here. It's going to request this alien page. If it requests that, it's going to look for this string CHTB. It's going to look for that, grab that out, grab the value out, and then it's going to send a new request to an endpoint we own with that specific flag. Now, I'm not going to bore you guys with the exact implementation of this or how it was written. I'm just going to show you guys the setup, and this is just JavaScript that we're building here, so you guys should be able to work it out. But here I have a Python 3 HTTP server running on my port 80. That's fine. But then I have ngrok running here, and I run ngrok by doing ngrok HTTP 80. And what this is going to do, this is just going to forward my local server that I'm hosting here. It's going to forward it to this specific address so that it's accessible from the internet, because this is not accessible from the internet. Now we can copy this address here. I'm quickly going to paste that into my payload, and I'm just going to paste this payload here in my feedback field. Okay, so this payload is going to do a bunch of stuff. I'll quickly show it in Sublime Text. So a new file here. This payload is going to load another library prototype, Angular.js. Then it's going to do the same, create the same diff ng app. And then here we have our whole ID here. It's going to fetch alien. This should just be alien. So fetch slash alien. If that works, then we're going to create a response and so on. And then it's going to send that through to document.location by setting that to my IP. Okay, this is just some way of exploiting XSS. You can do that in various different ways. This is definitely not the only one. So you can find tutorials for how to request data and send data and all of that. So let's try this out on our local host. I'm going to copy all of this. And I'm going to paste this in here. I'm going to submit that. And now I'm going to go and reload this. Okay, we see that we have gotten redirected to our ngrok page. And we also see that the flag or fake flag for testing obviously is included here. That is what the victim, in this case, that automated bot, will see, or what will happen to that bot if it visits that listing page. Now we can also see on our own server that at the bottom here, it saw those GET requests. So it saw that GET request, and it also showed the flag because it shows the GET parameters here. So that's cool. That's all working locally. Now the final thing is just to get this to work on the remote. So let's try that out. So on the remote, as feedback, I just have to paste in that script once again and send that. And now all we can do is pray that this is going to work, because there's nothing we can check anymore. But if we check back here, we see that, and let me make this a bit bigger, very big, because this is really exciting, because we see that a GET request to our /endpoint with GET parameter flag was made, and the flag is C_AgDebox, the whitelisted CND strikes back. And that is how we solved this challenge. So I'm going to submit this flag, and as we can see, that should be correct. Yes, that is correct. But In this challenge, we walked through a bunch of things. We saw a web challenge where we first of all identified what we wanted to do. We wanted to get that flag, obviously. We saw that we couldn't access that page and we needed some way to access the local host. So we kind of brainstormed what are our IDs, what could we potentially find that could allow us to get there. And eventually we saw that through a CSP bypass, we could get an XSS on their local host, on a bot running there, and we could coerce that bot into making a malicious request and giving us the data back that we need. And that is how we solved this first challenge through a client-side exploit. Now I'm gonna get into the second challenge of today, and that is Blitzpop. Now, sadly, we are running out of time, so I cannot go into everything in a lot of depth anymore, but let's go through this. So we have this page where we are asked what our favorite song is, and then at the bottom here, we can input some text, and I can submit that text. But it says at the bottom, please provide us with the name of an existing song. Okay, that's fine. I don't know what's going on here, but luckily, again, we get the source code and we can look at the source code. And our source code, again, has an index.js. This is, again, a Node application, this time using Express. So again, it's just a web framework. Once more, we want to look at the roots first to see what is going on here. And in the roots, we see an API/submit. And it seems that we can submit a song that's going to get unflattened and then compiled into Pug. Okay, a bunch of stuff going on here. First things first, I have no idea what unflatten is. It comes from flat, and flat is, I guess, a package. Here we see that's a package. Version 5.0.0 is here. Let's do some research. What is this flat stuff all about? So what I googled is unflatten flat 5.0.0 CVE. And immediately I find this page here. And this page talks about vulnerabilities. And right here it says there is a prototype pollution here. Let's take a look at the POC, the POC, and we see that if we unflatten something, so in this case, I guess there should be underscores here, __proto__ dot polluted is true. So now if we were to console log polluted, then that's going to be true as well. Whereas if we hadn't changed that prototype, then it would be false. Now, if you've never heard about prototype pollution, definitely do some more research here. It's a pretty cool concept in JavaScript, where every object has a prototype. And if, for example, you're trying to request a value on an object that doesn't exist on that specific object, it's going to check in the prototype of that object to see if it's there. And that's where prototype pollution comes from. But okay, we have a prototype pollution there. What else is going on here? Well, if we check it out here, our song that we can apparently pollute is only being used in this if statement, and it's saying, okay, if the name includes this, then it's going to do a pug compile. And else is going to say, please provide us with the name of an existing song. Okay, let's first of all see if we can make the name include that. So I have this burp session open here, and I can just paste it in to the post request. So the song.name is going to be not polluting with the boys. And then if we send that across, we see that, well, we get hello guest, thank you for letting us know. Okay, well, that's cool. This pug compile, what is pug? Well, pug is a templating engine. So it's going to take this template here, where this is the field it's going to fill in. And it's then going to fill it in with the user object, which just contains guest here. That's all. But we have a prototype pollution, and well, Pug is most likely going to request some values here on this. So maybe there has been some research into what a prototype pollution could mean when Pug is being used. So let's do a Google for that as well. And if we do so, we find that there is this block on AST injection. Now, sadly, I don't have the time to go into AST injections a lot. AST is a really cool concept, so abstract syntax tree. It's the idea where obviously your source code is not interpretable and executable, so it's going to go through a lexer, then through a parser, and then through a compiler, and then finally being executed. And that whole concept is really, really cool. But when prototypes come in there, we see that it can mess stuff up and lead to command execution. And this whole blog post is amazing. Definitely check this out. If you just Google AST injection, you will find it, because this goes through all all of the technical steps you need to know. But at the bottom here, it talks about Pug. It goes through an entire in-depth showing of why this prototype pollution will work. It has to do with the object.prototype of block, and here is the code and whatnot. Really great read, amazing stuff. Definitely read this. But at the bottom here, it also has an exploit for us. This is in Python. I want to do this in Burp, so I'm just going to copy the JSON here and get that into Burp. So, okay, filling that in here. All right, we can see all of that here. We can see that it's going to set the prototype of that block, like we also just saw. It's going to set the type to text. That's probably something specific to Pug in that case. And then it's going to do a prototype process.main module.require child process and then execute sync. And in this case, it's going to do a bash execution. I'm going to leave that out for now, and I want to go and do a netcat. So my netcat will have an IP, a port, and then -e bin/sh. That's what I want to do. Now I just need a outward facing, a public IP and port for netcat to connect to. So again, I am going to use netcat on my localhost again, as well with LNVP. I'm going to use port 555. And then here I'm going to do an ngrok once again, but this time a TCP ngrok hosting my port 555 to here 6.tcp.eu.ngrok.io and then 10704. So let's get that in here. So the IP address and then as port 10704, was that correct? No, because 10 is not just a 1. Okay, there we go. That should work. Now if I send this request, then we can see here that we receive a connection. And this connection, if we do an ls, we see that we get output. So we have a shell here. It's an ugly shell. You can probably upgrade this to a TTY and all that. But we see that the flag file exists here. So I can just cat that flag file, and that gives us the flag pollute with style. Let's copy that flag and paste that into the platform just to triple check that it is actually a correct flag. But obviously that is going to work. And that is the Blitzpop challenge. The whole goal of this challenge is obviously to get you to read up about AST injections. What are they? Why do they work? And they're a very complex topic. If you are going to do some more research on this, I would definitely suggest starting out with prototype pollution, checking out why that works, what prototypes are, and then this is all going to make much more sense. But that has been it for me. Today we walked through 2 challenges, a client-side exploit and a server-side exploit. We discovered some new parts of the world of web, and as you can see, it is pretty big. There is a lot of stuff to learn about here. This AST injection article, for example, is from 2020, and before that I don't think this was something well known or really discovered. So there is new stuff coming out in this field every single day, so you need to keep yourself educated, and CTFs like this one from Hack the Box are a great way to do so. Now, if you want to learn more about anything cyber related, then come check out my channel. I currently have a series running where we go through binary exploitation from the very basics, hopefully soon, right up to expert level binary exploitation. Let's see if we get there, but definitely come check that out if you're interested. But for now, that has been me. I'm PinkDraconian, and I just showed you 2 challenges, and I hope you enjoyed them.
And that was PinkDraconian. I think it was pretty much amazing to everyone. Thank you very much. I find it, I don't think I have ever exploited AST, so it was very nice for me to watch it. And for sure, I will try also to play these challenges because I have the privilege to work in the box. Yeah, and I can test them whenever. So thank you very much for your time. Thank you very much also for being in the chat to